Yes, and we're talking about Kelvin-Helmholtz instabilities. So let's just make myself very small. Okay, like this. Okay. Again, I can use myself as a pointer. What are Kelvin-Helmholtz instabilities? And I move over to the left side. You see here? Okay, I can, yeah, hey, I'm here, I'm over here. Can you see me? So what creates this type of turbulence is actually called a vertically sheared horizontal flow. Okay, we have horizontal flow. These are these red arrows from left to right and horizontal, but the speed of the flow changes in the vertical direction. You see, as you move down, the arrows get shorter, the speed is reduced. This is what we call a shear, okay, a vertically sheared horizontal flow. And what these, well, if the flows are strong enough, they can actually produce waves. And if the waves break, they can produce turbulence and mixing. It's illustrated here in this example, how it looks like. You have these flows and you get waves and then you get breaking waves. And this mechanism actually explains the creation of surface waves in the ocean. All right? Surface waves in the ocean and also waves in the atmosphere. Okay, here you can see a density. These waves can happen at density interfaces. Yeah, density interfaces are zones where there is a rapid change of the density. Okay, and you can see these breaking waves in the atmosphere, these beautiful pictures of, we call them billows, Kelvin-Helmholtz billows. You can create them in tanks, and indeed there are some artworks. All right, and let's have another look at another experiment to see whether you can spot these type of instabilities. They are very, very common in fluids. I forgot to mention, which is important, that you probably already learned that if you have unstable density stratification, you get mixing. And it's called convection. This type here is an instability mechanism that can also work in stably stratified fluids. You know, stably stratified fluids where you have lighter fluid above heavier fluid. Okay, this is how turbulence is created in the ocean. It's a key mechanism. So let's just get myself a little bit bigger again for the next part. All right. So let's move and have another look at one experiment with red color. Can you spot Kelvin-Helmholtz billows? Can you spot them? Let's get started. Okay. Can you see them? Can you see the billows? You see these elements, these little ones here? These are bigger ones. These are Kelvin-Helmholtz instabilities. And the dilution effect, the mixing effect, you can see because the intensity of the color actually decreases. All right, so that is one part, and let's see what comes on the next slide. Let's have a look at it. I think it's about the Coriolis effect. Okay, let's briefly talk about the Coriolis effect.